Hi, welcome back. So we're going to take a look at a few more examples of using the triple integral to find volumes. Now we're just going to set these up, but you'll kind of see the idea of how to set these up. Some of these are really difficult to solve. So let's go ahead and get started. We want to find the triple integral to find the volume that encompassed is the region in the first octant bounded by the following cylinder. So we're bounded by this cylinder right here. Now this cylinder is going to be on the YZ plane. So we'll talk about that in a second. You've got to remember how to graph these from earlier this year. On the YZ plane, and between the vertical planes, x plus y equals 1 and, sorry about that, and x plus y equals 3. So let's just kind of give an idea of what this at least looks like right here. I'm going to use blue here. So if we were to graph this, let's go ahead and graph our cylinder. Our cylinder is going to intersect the YZ plane. Notice there's no x values. So it is a cylinder. When I graph it on the YZ plane, it's going to intersect the z axis at 1. There's my z. There's my x and y, right? And it's going to intersect the y axis at 1. I'm only interested in the first quadrant. So it's going to look kind of like this. Now this is a cylinder, so it's moving parallel to the x-axis. So it's going to go around like this. There we have that. So there's our kind of our cylinder. Now we want to measure the volume underneath the cylinder, but between the following planes. So now we're going to graph these two planes. Well, my first plane here, this is just really y equals 1 minus x. So when we graph that, we're saying the y-intercept is 1 and the x-intercept is 1. So it's going to look kind of like this. And remember, it's going up. And then the next one, ready, it's going to be, what's that, y equals 3 minus x. So the y-intercept, the x and y-intercepts are both 3 now. Not drawn to scale. And we want the region in between them. This piece right in here. This is a region that we are going to project up to the surface. So we're going to project this region to the surface. And calculate that volume. So let's go ahead and find our limits. Okay, so we're going to find our limits right now. Now the first limit we're going to use is a change in z. Because I know my z. What's my min z? Well, my minimum z is going to be on the very bottom in the region itself. My maximum z is going to be measured to the surface itself. So I can get my my limit or my region of my limits, my region for z pretty easy. My change in z, it starts at 0 and goes all the way to the function itself, which is z, which they're told is 1 minus y squared. Right there. Now, the next one, so there's our change in z. Now we have to make a choice. Do we want to do the change in y or the change in z x first? Now, typically we like to do the change in y first. But this time it's going to be a little bit harder to do that. It's just not very friendly because if I think about this, if I make my rectangle vertical, I would have to use more than one integral. I'd have to use 3 integrals. So to cure that, I'm going to make my rectangles this time horizontal. So that's going to give me my change in x first. My minimum x will be this line. Well, I have to solve for x here, so the minimum x in this case would be, if I solve for x, would be 3 minus y. So my change in x, my minimum x will be 3 minus y. My maximum x would be the other line. Oops, sorry. Oh, got them backwards. There we go. This should be x equals 1 minus y. So my minimum is going to be, the 1 minus y. Messed that up, didn't I? And my maximum is going to be this one over here, which is going to be 3 minus y. So my minimum x, my maximum x. And now I'm going to find my change in y. Well, my change in y, well, my y values are going to start at 0 and go all the way to 1, because this is going to move up and down from 0 to 1. And now I can write my volume, my triple integral. I'm choosing z first, dz, dx, dy. Kind of like where I found them in this order, that's how I'm going to write it out. My change in z's go from 0 to 1 minus y squared. My change in x's go from 1 minus y to 3 minus y. And my change in y's are going to go from 0 to 1. And that will calculate the volume of our surface right there. Right. So let's go and use a triple integral now to find the volume of the upper hemisphere of this graph right here. So I'm going to go ahead and graph this, do the best I can. I'm a terrible grapher. So if we graph this, we want the upper hemisphere, so we want the entire top. Now these are dashed equal together, we can't see those. X, Y, Z. The radius is 1, 1, 1, 1, 1. And there's a height of 1. And I can kind of see how that looks. And I want to find that volume right here. So what do we have to do? Very simply is we have to determine what order do we want to integrate. Now I'm again going to use my x and y as my base. And that makes it a little bit easier for us. So that means the first thing I have to do to get my limits is to find the change in z. That's going to be easy. If I'm at the base, I go up, I touch the hemisphere. So that's going to go 0, minimum of 0, all the way to the surface itself. 1 minus x squared minus y squared. And again, you can kind of see why polars are going to be really nice for us. Now I have to determine, do I want to go horizontal or vertical? I'm going to go horizontal rectangle. Whoops, don't want to erase that. Don't want to erase that either. Everything's going away. There we go. And when I do a horizontal rectangle right here, this is going to give me my minimum y, and this is going to give me my maximum y. So to get those, remember, we can let z be 0. And if I let z be 0, I can get the equation of my circle. Of course, the equation of our circle would be x squared plus y squared, then would be 1. So my minimum y value would be the negative square root of 1 minus x squared. My maximum y value would be the positive square root of 1 minus x squared. So my changes in y are going to go from negative square root of 1 minus x squared to positive square root of 1 minus x squared. And then I go look at my x's. Change in x's. Well, I'm starting, it's going to go up and down, right and left, starting at negative 1, going to positive 1. Always remember the following. Your limits will always need an upper and a minimum value. An upper, or I guess I should say a maximum and a minimum value. So you always have to find what's my minimum x. That would be negative 1. What's my maximum x? Positive 1 right there. And once you have all of that, now we can write our volume. It's our triple integral dz, I'm choosing z first, dy, dx. So, and notice the complexity of the functions gets smaller as we move down. So we can go from 0 to the square root of 1 minus x squared minus y squared. So we're measuring z from the bottom, from our base. This is from the base to the very top of our surface. Our y's, that's my circular base. Now, so I found my volume, my heights. Now I'm going to multiply by my lengths. Okay, my length goes from negative square root of 1 minus x squared to positive square root of 1 minus x squared. And now I got to measure the width. And the width goes from negative 1 to positive 1. And that would be our integral to find our area. All right, go on to the next video, and we're going to take a look at one last example. I'll see you then. Bye-bye.